In 1980, Mount St. Helens exploded with the force of 1,600 atomic bombs and killed 57 people. But that eruption was filmed, predicted, studied. What I'm about to show you today is different. There is a submerged volcano connected to more than 500 miles of cables and sensors, monitored 24 hours a day, 7 days a week, with the most advanced technology on the planet. And even so, scientists could not predict what it was about to do. If even the most watched volcano on the ocean floor cannot be tamed by science, what does that mean for all the others? Stay until the end, because this video will change the way you see nature forever. And if you have not subscribed to the channel yet, do it right now, because every single day there is content just like this one waiting for you here. Axial Seamount is located about 300 miles off the coast of Oregon in the United States. To reach it, you would need to dive nearly a mile below the ocean surface. Down there, in absolute darkness, under pressure strong enough to crush a car like an empty soda can, there is a geological structure that scientists call nature's perfect gift. Not because it is beautiful, although it is, but because it erupts frequently enough to be studied, and calmly enough that no one dies in the process. Since 2014, the Ocean Observatory's initiative installed there what is considered the most sophisticated laboratory ever built beneath the sea. Hundreds of sensors are connected by a network of fiber optic cables. These sensors record every tremor, every millimeter of ground swelling, every rumble coming from the depths of the earth. They are so sensitive that they can detect the pressure of the tides. When the water rises a few inches due to the moon's gravity, the volcano responds with micro-earthquakes. It is as if Axial Seamount breathes in rhythm with the ocean. To install all of this, engineers operated submarine robots at depths of more than 4,500 feet. Imagine trying to plug a power cord into a socket inside a completely dark room, wearing thick gloves, while someone squeezes your lungs with full force. Now imagine doing that with a robotic arm controlled by a joystick, with a low-resolution camera as your only guide. That is exactly what happened. But it was worth it, because in 2015, for the first time in history, scientists captured an underwater eruption in real time, from beginning to end. And what they saw was surreal. The volcano's floor began to inflate like a giant balloon. Within hours, the ground rose several feet. Then came the earthquakes, thousands of them in a single afternoon. Then the ground cracked open. Cracks miles long split apart, and lava poured out silently across the ocean floor. The temperature difference between the lava and the deep ocean water was so extreme that the lava solidified instantly, forming pure obsidian, sharp, black volcanic glass. If you walked on it, the sound would be identical to stepping on thousands of light bulbs at once. As the lava flowed out, something even more impressive happened. A column of superheated water, called a mega plume, blasted from the ocean floor like a massive geyser. It rose thousands of feet above the seafloor, carrying bacteria that live under conditions that would kill every other known form of life. From a distance, this column looked like a white blizzard rising in slow motion through the darkness of the ocean. It was both a destruction and a rebirth. Each eruption erases the local ecosystem and forces life to start over from scratch. With all of this documented, scientists now had a reference point. They knew how the volcano behaved before, during, and after an eruption. And then they began monitoring the next cycle. The ground started swelling again. Earthquakes began increasing again. Everything pointed to Axial Seamount preparing for a new eruption, and the forecast was clear. 2025 would be the year. Researchers circled the date in red and waited. Nothing happened. The volcano reached exactly the level at which it should have erupted. The sensors showed the same patterns as 2015, but the ground did not crack. The lava did not come out. The volcano simply kept swelling, as if ignoring the very rules it had helped establish. It is the feeling of shaking a pressurized soda can and waiting for it to explode, but it never does, no matter how long you wait. Scientists have three hypotheses for what may have happened. The first is that magma is being injected more slowly than in 2015, meaning the volcano needs more time to build enough pressure. The second is that the rock around the magma chamber has become more resistant, holding the fractures with greater force. The third is the most unsettling. Small fractures may be releasing pressure in tiny doses, keeping the volcano in a state of suspended animation, ready to erupt, but never finding the final trigger. The problem with all these hypotheses is that they are equally plausible given the available data. Even with 500 miles of cables, even with sensors capable of detecting the weight of the moon, scientists still cannot distinguish between almost ready and about to break. So the forecast was pushed forward. Now they are talking about 2026, maybe mid-year, maybe not. And this is where things get genuinely serious, because the volcano keeps accumulating magma, and the longer it builds without erupting, the more powerful the moment it finally gives will be. An eruption in 2026, especially if it happens in the second half of the year, could be significantly larger than the one in 2015. This does not represent a danger to the coastline. The depth absorbs almost all the energy. No one will feel anything on the surface. But for scientists, the problem is something else entirely. All those yellow cables, all those state-of-the-art sensors, all that infrastructure that cost decades of planning and tens of millions of dollars is positioned exactly in the regions that could be hit by lava. If the eruption follows the same paths as 2015, the equipment might survive unharmed. But if the volcano is more pressurized than ever before, new fractures could open in unexpected places. In that case, researchers could be watching the live feed, see the image pixelate, shake, and then cut to black. Static. Equipment destroyed in seconds. But what really keeps scientists up at night is not the lost money. It is what the failure of the prediction actually means. Axial Seamount was the practice volcano. It was the place where the models were supposed to work. It was the controlled environment, the perfect laboratory, the easiest possible test. If science cannot accurately predict a calm, fully monitored underwater volcano with 2 decades of accumulated data, what does that say about our ability to predict the dangerous ones? The ones sitting beneath cities, the ones beneath densely populated islands, the ones that have been sleeping for centuries and could wake without warning. The honest answer is that we still do not know enough. And that honesty, coming from the researchers who literally built the most advanced observatory in history to study this specific volcano, is, at the same time, admirable and deeply unsettling. Meanwhile, down at the bottom of the ocean, life goes on with absolute indifference to all of this. Around the volcano, tube worms up to 6 feet tall cover the floor like a strange forest. They have no eyes, no mouths, no stomachs. They eat nothing. Instead, they host in their bodies bacteria that convert the toxic sulfuric gas expelled by the volcano into sugar. They are literally powered by pollution. Crawling over them are worms covered in microscopic scales that refract light in such a specific way that when you shine a flashlight on one of them, it glows in blue and red, like an alien Christmas ornament. The water that comes out of the vents around the volcano can reach temperatures above 650 degrees Fahrenheit. At the surface, it would instantly turn to steam. Down there, the pressure is so intense that the water cannot boil. It simply becomes extremely hot and begins dissolving the surrounding minerals, creating rock formations that look like they came out of a dream. And if you could hear all of this, the sound would be similar to a jet engine at full power on a runway. Scientists are now positioning special cameras in the hope of capturing the next eruption on high-definition video. Some talk about a live stream on YouTube. It would be the first time in history that someone would watch a submarine volcanic eruption in real time on a home device, a geological event of planetary scale playing on the same screen where you watch cooking tutorials and sports highlights. There is only one problem. If the eruption is large enough to open new fractures, the cameras may not survive to broadcast the ending. And then, the most incredible spectacle that nature could offer this generation would go unrecorded, buried under miles of water and silence. That is Axial Seamount, simultaneously the most studied volcano on Earth, and the one that still manages to surprise the people who should know it best. Nature, in the end, does not need our permission to do whatever it wants. If this video made you want to understand more about how the planet works beneath our feet, subscribe to the channel right now, because next week there is a video about another geological structure that most people have never heard of, but that could completely change everything you think about the stability of the ground beneath the world's largest cities. You will not want to miss that one.